Hello, my name is Kong. This video is a demonstration of Chronoconnect. Chronoconnect is a method that can track pathways along highly dynamic vertex in temporal graphs. Our motivation stems from the limitation of existing graph analysis system mostly based on static snapshots. Chronoconnect enable tracking temporal pathways in temporal graphs and prioritizing highly dynamic vertex in path queries. We use cross-snapshot path monitoring algorithm to examine how information traverses through this dynamic vertex in detail. And also, we offer an interactive user interface for graph validation and query result exploration. This is the snapshot-based temporal graph. It shows the changes from different times. From these three pictures, we can see these vertices do not appear high degrees of change at the same time, though we need a method for extracting significant subgraphs. We use the maximal K-core to identify a subgraph that includes all highly dynamic vertices called as the significant subgraph. In these snapshots, the colored points are highly dynamic vertex. Then we use the Dijkstra algorithm to find the shortest path from source vertex to the target vertex. It is the blue path and consisted of highly dynamic vertex. Considering maybe too restrictive for find chrono path, so we said find relaxed chrono path, which includes regular or non-highly dynamic vertex, like G node in the yellow path. And then it is the frequency-based path summarization to discover frequently occurring subpaths. This is our user interface. The website consisted of three main parts: algorithm, validation, and log output. The user can through the process step by step, selecting options, and see the output in both validation and log sections. Here, user can choose file to upload. I already selected the data. Upon selecting a file, the first step involves calculating the highly dynamic nodes. We can see the temporal graph shows the highly dynamic nodes at different times. We can also see that results at the log output part. Then the user can use K-core to calculate significant subgraphs. We can adjust the size of this part or just close it. Subsequently, the user can choose default method to calculate the chronopaths. We also set up a parallel approach to speed up implementation. Here is the chronopath, where different colors indicate the different subpaths. Considering that if chronopath is entirely composed of highly dynamic nodes, it may be too strict. So we introduced a relaxing path part. Here, we can see the relaxed chronopath, which may include nodes that are not highly dynamic vertex, thereby selecting more paths in this part. After finding all the chronopaths, we use an extract frequent edge algorithm to calculate paths that occur frequently. Here are the frequently occurring paths. That's our overview of user interface. Thank you for your attention.